Hello everyone and welcome to Tech Unveiled. Tech Unveiled is where we explore technology and invite you to meet our experts. And they will share their unique insights and views on different technical topics. My name is Lena Forsberg and I will be your host. And in today's episode, we will have a closer look at how to evaluate different processing options for radio access networks in 5G. Now, let me introduce you to the two experts who will help us unveil this topic. Gabriel Foglander, Strategic Product Manager in Cloudron. And you have been with us before, Gabriel, so welcome back.
Thank you, Lena. Great to be here again.
And we also have Söderlund, a network evolution expert in the product line RON Compute.
That's right. Yes.
It's your first time here.
It is.
Welcome to Tech Unveiled.
Thanks very much.
But let me start with you then, Gabriel. So how come evaluating processing options is so important for service providers right now?
Yes, so 5G deployments are well underway. We see tremendous uptake. So this is not new, but if you look at it, the expectation is that the traffic growth will continue to be tremendous. In fact, the Ericsson Mobility Report, I think, pinpoint this as 4 times what we see right now already in 2024. So that in itself is an enormous challenge to cope with. On top of that, I think most service providers are really keen to find new business opportunities. And here's a lot of talk about use cases, enabling critical IoT, fixed wireless access, capturing the enterprise value at the edge. And that, of course, is another challenge, and they need to bring in different components. On top of all of this, when they evaluate the network of the future, you also see the need to bring in new technologies, such as the cloud infrastructure that we've already seen enter into core. And this creates an investment decision to make. And in that part, of course, how to evaluate the processing options is really critical.
So in other words, working with multiple technologies will be key for service providers moving forward, right?
Exactly.
Yeah. Okay, let me then move on to you, Anders. So given this, what would you say are the key questions service providers need to ask themselves in order to make the right technology choices?
A first observation is that 5G networks today are built with Ericsson radio system, which is purpose-built hardware, like our basebands, radios, routers, and so on. So that will be the base. And then service providers should ask themselves, how can cloud infrastructure complement Ericsson radio system? That's the first question. A second question can be, where should processing take place? Decentralized at the radio site or at a centralized location? And thirdly, I think, combining the two technologies, different locations, how can you optimize the total cost of ownership?
Thank you. That gives me a much better understanding of the background to this topic. Thanks.
You're welcome.
To explain this a bit better, can you please elaborate on the different aspects of RON processing in this new landscape that we talked about?
Absolutely. We have to look at the 5G characteristics. 5G will come on new bands, mid-band, high band, with a tremendous wide bandwidth. So mid-band can be 100 megahertz, high band 800 megahertz. And so that puts tremendous load on the processing. And also the massive MIMO technology will also add load. And the time transmission interval, which is how often you transmit, this is shorter in 5G compared to 4G, again, putting load on this protocol stack.
Talking about the protocol stack, so I actually brought some Legos here. So could you use this to explain for me the different layers of the protocol stack? Because I never got it, really.
Absolutely. I'll give it a try.
Thanks.
So let's start then at the bottom of the protocol stack. Yeah. This is layer 1, which is at the bottom. And the massive MIMO technology and the wide bandwidth exponentially increase the load on layer 1.
So here, this is the big
Yes,
piece.
It takes a lot of processing to process massive MIMO and the wide bandwidth. So this is a, let's say, very important point. On top of this, we have the scheduler, which resides in the MAC layer, and we also have the radio link control on top of layer 1. And this constitutes the distributed unit, and is about 90% of the processing demand that is required in the RON protocol stack. Then on top, we have the central unit, which contains the user plane, which is called PDCP, and the control plane, which is called radio resource control. So that's the full stack then. And basically, the lower you go in the stack, the higher the processing demand, and also the lower you go, the higher the transport overhead is, which means that if you do decentralized processing close to the antenna, you can actually relax the transport requirements.
I see the challenges here.
Yeah.
But in your view, what could be done to address these challenges?
I think we should start by making a simple framework to how to think about it. So we have actually prepared something here.
Okay.
So, as Anders mentioned, we have the purpose-built hardware represented also from our perspective by Ericsson Radio System. And that consists of x86 processors that take care of the higher layers, as well as the MCA and Ericsson many-core architecture that also does the heavy lifting here in the lower parts. And on the other end of the vertical axis, you have the cloud infrastructure. And that also is utilizing x86 processor in the same way we do with the purpose-built. And in the same way, you have the same demand for the processing. You will also need probably acceleration here to take care of that as well. So these are the two dimensions from the technology standpoint. If we look at the horizontal axis, we have the decentralized deployment that Anders mentioned, which is beneficial for the backhaul reduction. And then you have centralized deployments, and this is done a little bit remote from the antenna site while this is near. And that gives some interesting opportunities also in pooling and co-siting that we'll come into later. So a simple framework on how to address the problem.
Thank you. That makes it much clearer for me. Thanks. Anders, I really like the way you explain the protocol stack with the Lego. So I have actually gathered some more Legos here. And I was thinking maybe you can use this to illustrate different deployment scenarios and their respective benefits. Is that okay?
I'll give it a try.
Okay,
No
you
problem.
take the challenge.
Okay.
Here you go.
I have even more at home. So let's see here. Well, this looks like a core network.
Yes, agree.
I put it over here. This looks like two towers here. Okay, so here you have the protocol stacks that we discussed before, right? You recognize those?
Yes, I do.
And then we start with the simplest deployment case, and which is actually also the most popular deployment case. And that is when you put the complete protocol stack basically at the antenna site. And this has the advantage that it lowers the requirement on the backhaul that goes up to the core network. And you can use any technology here, for example, microwave backhaul, which is used a lot in mobile networks. So that's the first scenario. A second scenario is when we move up to mid-band and use massive MIMO technology. And as I said, there is an exponential load on layer 1. And for this reason, we see that it's very beneficial to move parts of layer 1 into the massive MIMO radio. So what happens then is we put this part of layer 1 on top of the tower.
So is that the massive MIMO that?
Yeah, well, this illustrates actually the MCA that we have mentioned before, our tailor-made system on a chip that we integrate into the massive MIMO radio. And that does part of layer 1 processing, such as beamforming and full IRC receiver and so on. And that actually lowers the bandwidth that is required to connect to the rest of the protocol layers. And this interface that we have between the massive MIMO radio and the baseband in this case is the eCPRI or evolved CPRI interface, which is a packet-based frontal interface.
Good, but I mean, if I understand correctly, these are scenarios in a decentralized scenario,
yes,
right?
Yes.
But how would this look in a centralized scenario?
Yeah, maybe Gabriel, you can help me, so you can play around a bit as well.
But then I need some Lego.
Okay, I'll give you some Legos. There you go.
Thanks. So let's see if we can replicate a similar setup to what Anders explained. We still have the antenna towers. We have the core over here. And then we'll also take a look at this. The first scenario that Anders described, which is the most commonly used, that typically involves CPRI-based radios. And we have a little bit of a trick up our sleeve here to make sure that we could do that in a centralized manner as well. So what happens is we use the MCA to put it into a gateway or a router function, and that allows us to convert the CPRI into eCPRI. And that has the great benefit of it that it simplifies a centralized deployment, meaning that we move the full protocol stack to a centralized location in this case.
Yeah, maybe we can mention that the eZip interface is transported over the Ethernet protocol, which makes it a bit easier to build.
Exactly. And similarly to the massive MIMO case here, where we still have the unique advantage here of having the massive MIMO with integrated beamforming processing, this is actually eZip all the way, so natively. And that means that you have those great benefits that Anders mentioned already here. So the interesting thing about the centralized deployments is actually then that you have these in a centralized location, meaning that you can put them together like that and utilize the same infrastructure, connectivity towards the site, and manage multiple sites in the same way. And that gives some possibility there for co-location, site infrastructure, and also sub-pooling gains. You can actually take it one step further, because as Anders mentioned, the higher layers here are less processing intense. And that makes them quite suitable to do even further step of centralization. So we call it a disaggregated architecture, where you actually move the higher layers even closer to the core. And that has its benefits because the processing need is less, and it can also be co-located with core breakouts or edge deployments, so creating further flexibility in deployment scenarios.
I see, but then looking at all these scenarios, they have different benefits, as I understand. But how can we use the Ericsson portfolio to support service providers to maximize the realization of all these benefits? What do you say?
It's a good question. I mean, I think Ericsson value is that we have a very broad portfolio. And if I start with the MCA, this Ericsson many-core architecture system on a chip, the benefit with that, it's very powerful, it's compact in its design, and it's very power efficient as well. So it means we can integrate it into the massive MIMO radio and into the router as well to do the SIPRI conversion. And the eZipRI interface opens up also for execution on cloud platforms as well.
Yeah, and how would this look in a cloud infrastructure scenario?
Yeah, I think the value here is that you have increased flexibility in what you deploy on, right? For instance, here, this fairly lenient processing demands fits very well with the workloads that you typically associate with a core workload. So here you can get great synergies by using the same infrastructure in that same place. And furthermore, since you already often have the cloud infrastructure in place from the core deployments, then you can reuse the same harmonized platforms throughout. So that also has some potential in operations and maintenance gains, which is also a not insignificant part of the consideration here. So those are two great examples. Additionally, if you look at it a little bit further, you can take one of these scenarios if you're looking at a targeted deployment, for instance, for an enterprise or an industry, and you can use the same setup that we have over here with a decentralized deployment or near antenna deployment, on a commercial off-the-shelf stack. So having the cloud infrastructure to deploy on makes it more easy to combine the workloads of the applications that runs on top and the actual connectivity from the cloud run. And that has its benefits because a typical enterprise or industry location do not have staff that is experienced in managing the purpose-built hardware, whereas they normally have an IT department that can handle a traditional server. And finally, you can also solve an important piece of the puzzle here that talks about the data sovereignty. So data is really important for industry and enterprise applications. And having it on site is an additional protection, and it also allows you to explore it with machine learning and AI technologies to mine value for that. So this could be an interesting scenario for cloud infrastructure.
Great explanation of all these different deployment scenarios. Thank you. Coming back to where we started the conversation, what would you say that service providers need to think about when it comes to evaluating different processing options for 5G RAN?
Okay, maybe I start?
Yeah.
All right. I think there are some technology agnostic checkpoints that a service provider should think about. The processing solution should be future-proof, not just to handle the traffic growth that we anticipate in the networks. And also, we're just at the beginning of 5G. There are many new use cases coming down the line. And also, as we have discussed today, it's important when analyzing the total cost of ownership that you analyze both RAN and transport together, because we have seen that decentralized processing will actually lower the requirements on transport.
A good point.
Yeah. And I mean, it's really interesting also because another thing that you need to take into consideration is the pooling gains that you can achieve here through centralization, which is actually a trade-off here versus the investment on the transport side. So even if you might need to invest a little bit more in the transport, you can gain a little bit in the processing option itself. Another really important thing is to think about the operations and maintenance aspect of this, because the TCO stretches all the way there as well. And there, I think it could be a benefit to have a more harmonized approach that you can have by introducing the cloud infrastructure across many domains. And if you can do that, you can utilize the same O&M tools and the skill sets throughout. And lastly, I think not to underestimate is the actual physical co-location that we talk about here when we say that we move things for the core, we move it further towards the RAN, and for the RAN, we might be looking into centralization, and then we also have the edge coming into the picture. So finding the appropriate balance here for co-location and the physical site infrastructure and getting synergies across that is also really important.
I mean, it's been super interesting to have this discussion with you, but unfortunately, this session is soon coming to an end. And I was just thinking, I mean, if you, Gabriel, if you were to summarize the discussions we have had here today, what would be your key takeaway?
Yeah, if we connect back all the way back to the challenge that we described on traffic growth and also ability to address new use cases, I think the Ericsson standpoint here is that we need to take a complementary approach towards introducing cloud infrastructure technologies on top of the proven methodologies that we have in the RAN portfolio. And I think we will show that that is a ROI-friendly approach to take that complementary road. And that gives us a good platform to advance the network into the future and meet the needs of our customers.
With those concluding words, I would like to thank both of you for taking the time and come here and unveil to us how to best evaluate the processing options for 5G RAN. And of course, I would also like to thank all of you for watching. It has been a true pleasure to, together with our experts, share our views on this important topic. And I do hope that you found it interesting and would like to further engage with us to see what this would mean to you. This was a third episode of our Cloud Run series. In our next episode, we will take a deep dive into 5G mid-band, and we will unveil what is needed for a successful implementation. So I hope to see you then. Thank you and goodbye.